You can use BIM with a bridge, a road, a tunnel, or a complete infrastructure, also with a building or a complex of buildings. BIM is available for the entire life cycle of a construction project, from design through construction, management, maintenance, even to demolition. Who works with BIM? With BIM, each individual party makes their own contribution to the virtual structure. The architect, the contractor, the builder, the consultant, the installer, the glazier, everyone. This works well as long as all components satisfy everything agreed upon in the object library. Only then is there one language understood by everyone. You can study the project and see the library components before construction begins. Information about construction, maintenance, costs, and safety all comes from the same source, BIM. But not everyone needs all the information. So, BIM also contains an agreement about who can look at what and who is allowed to input to which sections. Why BIM? BIM exists to enhance the performance of a construction project or network infrastructure. This is possible because the information is standardized and available for the entire life cycle of the structure. With BIM, you get better cooperation and decisions are easier to make. In any case, it is a fact that with BIM, the sky really is the limit.
Probably the video gave in a bit of idea about what BIM is, and I'll quickly share a little bit more about what BIM is. BIM is a way of working, and it is not just about producing the 3D models. It is actually an information modeling, and it is about managing that information in an environment. It is all about data. And we kind of have three key deliverables onto a BIM model. So that's the individual 3D models in the native file formats. Those could be your DWG or your Revit models. And of course, they are your 2D reviewable design deliverables, and those are derived from your 3D models. And you also have something that is known as a facility management data. So we will come back to what a facility management data is in a couple of slides. And that is quite interesting because I'm sure we all kind of relate to what's a 3D model and what's a 2D, but facility management data is a bit different, and it's quite interesting. So 3D model is just a way of presenting the data, and it's also a way of communicating our designs. So when we talk about BIM, we actually don't talk only about it being 3D, it being a visualizing tool or a modeling. So what can a BIM be about? It is actually about a better information management, and it's in a team environment. We all know that because we work across the globe and we have teams that are as big as 80 to 100 people, it is quite a task to actually manage the information. And we run that risk of diluting and interpolating the information. We run the risk of actually using superseded information to carry out a piece of activity and whatnot when we don't have a proper information management in place. So BIM is all about better managing this information so that we work to the right data. It is also about increasing the efficiencies through early problem detection. Until a few years ago, we have often seen issues where the constructing activities with assets often clashing with each other, or identifying a potential interdisciplinary problem or a clash at the last moment, which then takes a huge amount of rework involving a lot of time, effort, and money to rectify. So with BIM, it gives us a tool to identify these clashes at a very early stage of design so that we don't have to go do that at the very end of a project lifecycle. Thus, it helps us in saving rework as well. It is also all about how we handle the data. So when we talk about a design information, it consists of drawings, it consists of model, which are nothing but our graphical data. It can also consist of your schedules, information, and specifications. So BIM kind of gives us a tool to better handle all of this data, whether it's a graphical and a non-graphical, and it also helps us in reducing the chances of manual errors while we are doing it. BIM also helps us harmonizing those data together for a better and coordinated output, which helps saving time, energy, and resources, and of course, the operational stage. So we can also call BIM as maybe a better information management. So when we go to what does a wiki define BIM as? So it is defined as building information modeling. It's a process that is generated and management of digital representation of physical and functional characteristics of the places. So the next slide actually speaks about what is the inputs and the outputs of our BIM models are. So we will go into a more detailed analysis of it in a couple of our slides later. Now we'll come to what are the BIM dimension. So the BIM dimensions are the 3D. And currently that is where most of us working are in a 3D BIM environment or a 3D dimension. So this involves the coordinated model that we discussed in the previous slides and any asset or a facility management solution that we may be doing. The 4D is all about the construction sequencing part, which currently it's majorly done by the contractors. The 5D is the estimation and the costing. And it is possible that it is integrated onto a BIM environment as well. The 6D talks about the project lifecycle BIM. It is more about the facility management, and it is about what are the data that is needed while a project goes on to management and operations, or what we call as an O&M. The model that we produce usually has the asset management information in it, but mostly these are again done by the client, the end client, or the maintenance contractor during the operational stages. So now that we have seen the BIM dimensions, what we will go next is the BIM maturity levels. How has BIM developed, and what we mean by when we talk about a BIM level 2, how have we progressed to BIM level 2? So level 0 is when we are used to do things which were manually and it was not in any shared environment. So maybe a couple of some decades ago, we were just doing 2D CAD environment, and it was whatever cooperation was there was through phones or through email. So we basically did not have a common data environment, and there was no models that existed as well, which was not shared. Then we moved on to level 1, and the level 1 is the managed CAD in 2D and 3D. So here we kind of have a shared common environment, also known as CDE, and I'll come to it later as well, and I'll show you what a CDE is. We tell it as a common data environment. We still do not have collaboration at level 1 or coordination. 2D models are available, but only for specific disciplines to which it belongs, and it is not something available for everyone to go into it and look into what coordination and collaboration is all about. So then we moved up to a level 2, and that is currently where we are. And we have a CDE, a common data platform, or a common data environment, and each disciplines kind of puts in their data into their environment. And it can then brought together and checked for clashes during the interdisciplinary clash checks, and it can lead to a final federated model which can be submitted to the ultimate client. This level at times also has 2 additional dimensions introduced, which can be the 4D and 5D. So the 4D is about the time management, and 5D is about the costing and the estimating part about it. Finally, the next level is level 3, and that is where we will kind of have a full collaboration. It is something that you can do over the cloud. It will be cloud-based environment, wherein every model can be shared and modified at the cloud. So you don't need to rely on one of the disciplines for a particular change. Maybe it can all be done at a real time on the cloud, and you can instantly see what that effect of that change is about. And it will also help us in eliminating the conflicting data and clashes in real time without need of having those separate interdisciplinary clash checks. And then that would make things more easier, and it will bring the cost cycle management information more better and more managed. So now that we have understood the key definitions of BIM and the key dimensions of BIM and their maturity levels, onto the next slide, I'll be talking about the region-wise adoption of BIM. I think this is of interest because we would want to know where the major countries stand in kind of BIM demand and where we as India stand. So the first and foremost among all of them is the United Kingdom. They have a government mandate for a level 2, and the government has a BIM task to lead and oversee it. And hence, of course, when you have something that is being pushed from the top, you actually have that drive to implement it as well on the ground. So UK is kind of leading that, and because we work more on UK projects from a Jacobs perspective, we kind of have that developed toolkits and tool palettes available with us. So if we come next to US, so US again were the early adopters of BIM, but because they did not have any mandate, there hasn't been any real progress on the BIM side. So they don't have any government mandate to have it. There might be isolated requirements, but it is just every now and then. Australia again doesn't have any mandate, but the enthusiasm is great, and kind of all agencies intensifying their effort to promote and adopt BIM. For Middle East again, there is no mandate right now, but of all the countries, UAE has the highest level of BIM implementation, and we as Jacobs, when we work with the Middle East countries as well, we are kind of developing the toolkits for Middle East, and we are kind of understanding what works well with their codes and what are the good lessons that we have learned from UK that we can actually go ahead and replicate to Middle East. Coming to India, again, India has a great interest in implementing BIM, but it is again comes down to the market competition and again to the cost hindrance that kind of hinders to the adoption of BIM here. So if we conclude, so we can say that UK is kind of way ahead with rest of the government mandates in place, and because it has an advancement to level 3 as well. For Middle East and Australia, there is no mandates yet, but we see increased interest and queries there, and we have been having that focus area from a Jacobs point of view to actually go ahead and have those BIM implementation in the projects that we do with the Middle East client. Again, for India, maybe it needs to come from the clients. We need to talk about the benefit, about the BIM that it can offer, and of course, it is about convincing them to adopt BIM. And maybe this might be just a very good platform because you all young engineers, maybe when you go out, that might be a very good way out to go ahead and talk about BIM and what benefits it brings to the clients in India, so that we can go ahead and implement BIM in our projects as well to a much larger scale than what it is now. So I'll next go to the BIM processes and what are the standard BIM processes here. So this is the life cycle of generally of a project, and the very intention of showing this here is that BIM has to start from the very beginning of the project. BIM has to start at the proposal stage, or maybe what we are we know more it as an RFP stage or a bidding stage. BIM has to start from there. It has to come from the client. The client has to have that collaboration in place, and that is how the BIM gets into place. You can't do BIM at an end of a project. BIM has to be started from the very beginning of the project. So these are the various cycles, and it talks about what information is needed when we also need to see that the supply chain can deliver it, because we just can't build something that can't be constructed. We also should be knowing who delivers what and at what point in time. And of course, so when we start with the project, we kind of have very limited information, or we kind of have very limited modeling or data information. But as we progress with the design and then with the construction, and then you see that the information actually grows here. So until through the design to the construction, your information grows, and then it consists of your graphical, non-graphical, and documentation data. And then you then go on to your OM, or the operate stage, and that's when your kind of the information is a bit stagnant, and you already have all the data that the project needs to go onto an operation and maintenance cycle. So we have spoken about a level 2 BIM. So what is a level 2 BIM? And you can relate it to the previous slide that I have shown. So a level 2 BIM actually consists of an EIR, that's an employer's information requirement. It is defined by the client, or if we talk about a domestic project, maybe that's an RFP that we kind of are more tuned to hearing. It is all about the supply chain evaluation, understanding their commitment and capability of delivering it through the whole cycle. We also need a BIM execution plan, which defines and is a response to the EIR, and it says that what we are capable of doing on a BIM execution plan. It also talks about the common data environment, and it is of utmost important, because when we put everything at a common place, security and the data management is of utmost important. I think when I showed the video at the very beginning, it talks about restricted accessibility to the data, and common data environment actually has that thing inbuilt in it, so that you can have a restricted data accesses to what particular set of data you need. It is again the single source of truth, so everything will be kind of extracted from that common data environment. You will not be working on your personal drives. You will be actually working on that common data environment. And of course, we need the codes which kind of standardizes the data structure and workflow. And of course, at the end, what we get is a project information model which has our geometrical and non-graphical information. The finals are the deliverables. So it is all about the geometry and the non-graphical, that's a PIM, and then the project outputs, which are the documentation part. So when we work on a BIM project, what do we deliver, right? So that's of utmost interest. So we deliver a project information model, and that kind of consists of your graphical model, and so it is an assembly of each of the discipline-specific models that you have. It could be your highways, it could be your drainage, your road restraint systems, your pavements, your fencing. It can be your structures. It can be everything. And then you have your non-graphical models, which are required when you go into an asset management of the facility, because it is not only important that we construct something, but maintaining and operating it is equally important to derive the correct benefit out of a project. And then, of course, we have the project outputs, which are the drawing, reports, certificates, and contract documents. So how do we derive the project outputs? So when you combine the graphical and the non-graphical data, is all about what you get as project outputs. So the next slide talks a bit more about the non-graphical model, just because we are more attuned to the graphical data. The non-graphical model is more about the construction information. It is about the asset information modeling, and it is about the asset management information as well. So now that we have seen what are the various processes of a BIM, so what does it actually look like? So in a traditional workflow, we would be doing everything as a staggered approach. So you concept, then you design, and you analyze, and then you maybe visualize, and then document and detail, and then there is a collaboration. Whereas if we see onto building information modeling, so it is all about putting in all the data together and then coordinating it and analyzing it, not separately, but all at a time, so that they are all real time and they are in one single model, and we can detect the clashes and understand where the clashes are, and so that we can rectify it at an early stage and not later somewhere during the project construction stage. So that brings in more of a collaboration, and that helps us in understanding the project in a much granular way at the very beginning of the project. We don't need to wait till the end of the project. So once we have found out more about what BIM can do and the amount of digital information it has, so I think next would be of interest to see what is the benefit or the business value from BIM is. So if we look here, when we are at a BIM maturity level, which is much lesser, we are putting in all our effort to our deliverable creation. But as and now, as we increase our BIM maturity levels, the deliberation creation needs less effort, whereas your model creation needs more effort. But and it's quite interesting to see when your BIM maturity has increased at the very initial years, the additional effort in design and new processes are a bit higher. But as we move ahead, the deliverable creation and the model creation both needs lesser effort, and then it subsequently increases, which means that it is reducing both your effort to reduce your modeling and deliverable creation, and it is continuously increasing your efficiency gain. And of course, your quality is a primary here, because when you go ahead and deliver with quality, that is where you would be doing less iteration, and that is where your deliverables would be right at the very beginning. So now that we have understood a lot about BIM, I'll again go ahead and show a video, and this is more about a project, kind of understanding what that project talks. How do we do a project that we start from a concept stage, and what it does, and how that data, if it is together shared, makes things so easy for us, and how you can see everything together. So the bottom line of the video that we saw is kind of, it is modeling about the right thing in the right size, in the right place, to the right units, and of course in such a way that everyone can slice it and dice it for their own database use. And it should also have our unique identifiers and asset information from a linked database so that we get the right information at the right time. So now that we have seen about the projects, what our processes are, I'm sure you all must be interested to know what are the tools that we have so that we can actually reach, or we can actually go ahead and do something that is all about BIM. So so the first thing that we had mentioned about is about the common data environment. So ProjectWise is one of the common data environment that we use quite frequently, and it's a contractual agreement obligation for the UKs. So and why do we need a common data environment is because it is all about the sharing methods, it is about the facilitating the global Jacobs procurement, and it is also talks about the increased collaboration, efficiency, and security. I have specifically highlighted security in red, the reason being I'm sure we all would want to know that when so much of data is on a shared data environment, what do we do about the security? And so the CDE is a platform that keeps our data secured, and it only gives accesses to the places that one needs and not to everywhere. So I'll just go to a few basic things on a CDE or the ProjectWise, because that's what we kind of use quite significantly here. And so the ProjectWise kind of shows the deliverables, and it also needs an unique naming on the deliverables. So just to give you a rough idea and a flavor about what does a ProjectWise do, and it might be something quite related to a particular project or a particular client, but we kind of need a project code and an originator, then a volume, and then the location code to actually uniquely identify a file on the ProjectWise, because it is very imperial that we have the files that are uniquely named, so that when we go ahead and talk about data, that data is unique. That data is not repetitive, because if you have repetitive data, it is not secured, and secondly, you can have a superseded data that you are using, and that might jeopardize your entire project cycle. So having an unique file naming strategy is a very key onto a ProjectWise, and hence it is very critical to have it right at the very first time. You just can't create 100 files and then go back and change them. That's a lot of effort, and then a lot of effort, and it reduces your efficiency as well. So we touched upon the security, and I'm sure you all must be then willing to understand that how does the quality check happen if everything is happening onto a system that is in a server and it's a common data environment. So having a strong craft procedure, that's what we call as a craft strategy, is very important. And it starts when we produce a document in the ProjectWise. And then if that document has been produced in the ProjectWise, then the originator actually checks the document, whether it is correct, then it is well and good. It then goes to your checker and to the reviewer, and then it goes through a cycle, and then you do a craving, and then it is passed on to the client. Just in case if it is not a yes, and if it's a no, then it again goes through the entire cycle. So having quality checks in place is absolutely important to have the right information and to have the right deliverable at the very first place. So even though we talk about BIM, we talk about common data environment, but ultimately having a quality deliverable is absolutely imperative if we want to take the advantages about BIM at all. I'll pass it over to Saurav now. Saurav, over to you as you run through the tools for our graphical models.
Yeah, thank you, Nivedita. And just before going into this one, I just remembered something as you were telling about file naming conventions. So, means how important file naming is for us. In my previous organization, there was one person who left our organization. And when he left, the last bit of task he was given, he did not hand it over to us, and he left suddenly. So we were searching through his computer, which we are searching through his system to locate that file. And we saw a file named Raj Kaj Shesh. So that person's name was Raj. And Kaj Shesh in Bengali means is the last work he's doing. So he named it, it's the last work for him. So he named the file like that. But you know, means hearing this, you can understand how confusing it gets and how irritating it gets when you have hundreds of file names in that manner. So yeah, means it's very important to name files correctly. Okay, anyway, continuing. So ProjectWise and common data environment, Nivedita has already mentioned. So the modeling tools that we have with us, first is Autodesk Civil 3D. And this is to model in the highways parameters, drainage parameters, everything. So in terms of highways, the screenshot that you see there is from a 3D model for a highways design that we did. And on the left-hand side, you can see output from that model, and that's in Navisworks. So yeah, means Civil 3D is the main software that we are using, but as we are progressing, new software is being developed. So we also have Open Roads Designer with us now. So we have quite a few resources who are working with Open Roads, and we are developing in Open Roads as well. So, but yeah, I mean, still now for UK, the main software that we are using for geometry design, road geometry design, is Civil 3D. So, Nivedita, you can just click. Nivedita, means, did you stop sharing? Should I share it back?
No, I'm sharing. Give me just a moment.
Yeah. Yeah, just press click. Okay, if there's an issue, I can take it up from here, and then I can hand back to Nivedita when. Okay, and let's see if this happens now.
It is not letting me move to the next one.
Okay, I will share my screen back in that case.
Sure.
If that's okay, yeah.
Yeah, absolutely.
Can you stop your sharing? Yeah. Is my screen going through now? Yeah. Okay. So within Civil 3D, so this is the Civil 3D window that you can see. So on the top right-hand corner in the menu bar, you can see the Jacobs DD tool. It's written as Jacob DD tool. And the sub-assemblies, means if any one of you is knowing Civil 3D, it consists of, means in order to design a road, you will have to build up the road cross section. And for that, you need to build it one element at a time. And for that, we have a range of sub-assemblies. And the one in the middle of your screen that you can see is Jacob's internally developed sub-assemblies. So yeah, means we have made quite a bit of progress in terms of this generation of toolkits, BIM toolkits, and other things. And in UK, so Jacobs is the pioneer of such a toolkit. So we are having a full range of BIM toolkit involving these sub-assemblies, tools, documentation, guidance, whatever means you can think of in terms of BIM. We have a range of, means we have suite of things. So it's called a BIM toolkit. And when Jacobs developed that, Jacobs was the only company at that time which went to that level. The other companies had issues with other things, but yeah, means I will not go into those issues. But yeah, means there's quite a bit of development that has been done. So the next tool that we are using for graphical model is, sorry, what happened? Yeah, so Civil 3D for drainage and Windows. So these are the two software we use in terms of drainage design. And there's a screenshot for that too, as you can see, with a manhole and a few pipes going around. For technology and street lighting design, we have Bentley Sue. Yesterday, I was mentioning in the smart motorways call, we need to design each and every sign face in great detail, including the text heights, text widths, that blue part you can see, the width and the size of those things. So everything has to be designed in detail, including the posts and foundations. And on the right, you can see the road markings. So each and every element of that road markings, including the arrows, size of arrows, those chevron markings, for the individual broken lines, dashed lines, the size of each of those dashes need to be designed in detail. So for those things, we have a software called PDS. So for road design, for traffic, for signs, we are using PDS sign, and for road marking, we are using PDS lines. Next, we have Autodesk Revit for structures. So this is we need to get everything together in Navisworks for the federated model, and for structures we use Revit to convert it to Navis. Then we have AutoCAD 3D, and why I wanted to show this to you is that CDM. So the one that you can see, CDM HNS information. So HNS is health and safety. So in UK we have specific regulations for health and safety. And the triangles, the hazard triangles that you can see there with the exclamation mark, those are to convey the risks. But if you are struggling to understand what CDM and health and safety and all those hazard triangles are, I have a bit here. So CDM basically is UK regulations, and as per UK regulations, being a designer, you are responsible for the safety of your design. So when your design is constructed on field, so if anything happens due to a faulty design, that's your responsibility. So, and you have to be responsible for that, and to eliminate or to take care of any risks or hazards, we have this principle. It's called the ERIC principle. But just to understand hazard, just as an example, say you have designed a curve. So you are studying engineering and you are studying roads and curves and all those things, straights and curves. So say you are designing a curve, but you don't design a super elevation. What happens? Due to the centrifugal forces, there's every chance that the vehicle will face an incident. And if an incident happens due to that reason, as a designer, you will be responsible, and you will be prosecuted for not providing that super elevation. Now, how to take care of that hazard? The first option is to eliminate. The first priority is to eliminate. So in terms of the example that I gave just now, how you can eliminate it is to provide a super elevation. So that's elimination. The next priority is to reduce any risk. So if you cannot eliminate something, you need to reduce the risk as much as possible. Next priority is isolate. So if you cannot reduce, you isolate it. So say you have, like yesterday I was mentioning those hazardous chemicals or hazardous invasive plants and other things. So saying by the side of your site, by the side of a road that you are building, you have an invasive species, say a giant hogweed or a Japanese knotweed, you have that type of a plant there. So what you can do is you can just barricade it so that nobody touches it and nobody can go near it. So that's the way to isolate it. And finally, if all the three fail, then the last option is to control. And how to control is, that means the hazards that still remain after the three priorities that you have done is called the residual risk. So you need to inform that residual risk to all users. So in this case, the road users or whoever is constructing that. So that's what we intend to do with those hazard triangles. So at every hazard triangle that you can see there, we have a specific residual hazard which we are communicating to the contractor in this case, because that's a construction hazard. But if that hazard will be faced by the road users as well, we will need to inform it to road users. So that's what we do by those warning signs, if you have seen. So if you are going to a level crossing, you may have seen a warning sign that it's a level crossing, you are approaching a level crossing. So that by that way, we are communicating the residual hazard to the users, road users. Next is like Nivedita was telling about federation, coordination, collaboration, clash detection. So this is the software we have for clash detection, Navisworks. So what we do is all the disciplines, highways, structures, drainage, technology, all disciplines input their design or export their design to Navisworks. So Navisworks is a common platform to export their design. And the digital delivery team, the project information manager, will go through that in detail tomorrow. But yeah, the digital delivery team gets all those individual discipline Navisworks together into a single federated model. So the picture you can see in the bottom of your screen, that is a screenshot from a federated model. And you can see every discipline has inputted there. And that way, you can just move about or navigate around in that Navisworks window to detect any clashes or to see how everything is sitting with each other. And we have a video which I want to play. Let's see. And this is from a Navisworks model.
Utilizing the rich 3D models produced in design, teams can identify and resolve issues virtually before breaking ground by visualizing projects holistically, modeling constructability, and performing clash detection. Navisworks Simulate and Navisworks Manage can use model data from Civil 3D, aggregated with information from other sources, to help engineers minimize costly errors by performing simulations and analysis before construction begins. Additionally, if interferences are identified with Navisworks, the link back to the dynamic 3D model within AutoCAD Civil 3D enables engineers to more quickly update designs and related documentation. With improved coordination between designers and construction teams, the volume of time and cost-intensive change orders may be reduced. When it is time to break ground, enhanced 3D models can be used to sequence construction activities and guide construction equipment. With help from Autodesk Navisworks products, project engineers can visualize 4D sequencing to help improve staging and scheduling, and to better direct field teams. This can help speed project completion by reducing idle time for workers while helping to better predict leasing, maintenance, and fuel costs for construction equipment.
Yeah. Hopefully that gives a bit of overview of Navisworks. So the other tool that we have, and this is mainly for visual users, visualization, is Autodesk InfraWorks. So the screenshot you see there is from an InfraWorks window. So you can quickly produce visualization models, which looks good to actually see. So those road markings, the road geometry, everything can be roughly designed in InfraWorks. Or after the main design happens in Civil 3D, you can export that design to InfraWorks as well. So we again have a view of InfraWorks visualization. Yeah. So let's see the video. So that's about graphical tools that we are using. So for non-graphical tools, so we were discussing about non-graphical data, asset data. So Jacobs, in association with Autodesk, sorry, I spell mistake there. Autodesk has developed an asset management solution. And yeah, sorry, I cannot show that to you right now because I'm in the tab. But yeah, means what do you mean by asset information? So I think Nivedita has already explained that in brief. But basically what that means is every asset within a field, within a site, say you are putting in a light post, lamp post, or you are putting in, say, a CEC cabinet like we were discussing yesterday. All those have specific properties attached to it. Say for a lamp post, light post, you have the post size, post height. Even for the bulb, you will have the luminaire for that bulb, the what should I say, the wattage, like you mentioned. So the luminaire of the bulb will be specified, and that is designed so you cannot just go in and fit in a low luminaire bulb over there. Otherwise, the lighting won't work. So what it does is we just build in the asset information into that element of design. So when the contractor goes to field or the maintainer goes to field, if he sees that asset data, he can just check up the federated model in Office itself, and he will be able to understand the luminaire of the bulb he needs to replace. Okay. So say I'm just giving you two examples. So say for that lamppost, the bulb has fused. It needs to be repaired or replaced. So if we don't have the asset data built in into that element, what will happen is the maintainer, when they try to replace that bulb, they will have to go to site, check the luminaire of the bulb, come back, procure the bulb, and then again go to site to fix that bulb up. But if we build in the asset information within the federated model, and because we hand over the entire federated model to client, what happens is that data sits in Office itself. So before going to site, the maintainer can just open up the federated model and check the luminaire of the bulb we designed, and then procure it and go to field just one time. So that's the importance of asset management solutions. So this asset management solution will enable us to manage the data that we are required to hand over at each data drop. So you guys, means Nivedita was showing that life cycle. So in the bottom, if you have seen it, at every stage of design, we need to transfer data to client. And every time we do that, it's with this asset management data. Yeah, okay, so that's about non-graphical. So this is a video of a non-graphical model. So you can see that sign face there. Oh, sorry. Let's, for some reason it's not running. Let's see if, for some reason the video is not playing. Some technology issues, maybe.
Do you want me to share my screen and play it? And
yeah, maybe.
Yeah.
Okay, it means if I go out of the slideshow, it may play. Just a bit, just a second. Okay. Nivedita, I think it's not playing when you go to slideshow. So just go out of your slideshow and play it. It will play. So as you can see, the traffic sign there has these bits of data attached to it. So in the Navisworks window, if you just click on an element, the properties of that element will appear on the right-hand side. So that's what is happening. As you can see, each and every element of that road, even the sort words, the hard shoulder, carriageways, everything will have data attached to it. And for that road marking that has been selected now, you can even check the road marking type, because from road marking codes, even for dash lines, there are quite a few types of dash lines. So even that type of dash line that has been used will be displayed there. So that's the central reserve barrier. And it's a huge amount of information, as you can see there. So especially for traffic signs, there's a huge amount of information for those assets. Yeah, so Nivedita, you can keep controls, I think, but just go to slideshow now. So now we can move on to a few sample projects that we did. So this is the first sample project that we did for BIM level 2. As you can see there, it's the first BIM project pilot scheme for BIM level 2. And what we did there is practically everything. So from alignment design, roundabout design, as you can see there, even the clash detection, and obviously means the pavement design, traffic signs, they are all there. And for the non-graphical parts, you have the specifications, drawing production, and technical assurance packages, all those things. But as I mentioned, this is a pilot scheme for BIM level 2. Unfortunately, because it was the pilot scheme, we did not have a very well-defined EIR or a BAPE. There was one, but it was a very basic one, which is nothing compared to what we have nowadays. So yeah. Nivedita, you can go ahead. Next slide. Yeah, this is quite a recent project. In fact, it's still now happening. So it's the Manchester Northwest Quadrant. The project was just about designing a few ring road kind of roads to just decongest the Manchester city. And it's a fully level 2 compliant project. So we have a full range of suites there. So as you can see, EIR, BAPE, MIDP, TIDP. So EIR is employer's information requirement, as Nivedita has already mentioned, what client needs for us. So that is supplied by the client. Then we have the BAPE BAPE is produced by us in response to that EIR. MIDP is model information delivery plan, and TIDP is task information delivery plan. So those things TIDP will be for each discipline. It will be one each for each discipline, and it will detail out the deliverables we need to produce. And MIDP is combination of all those individual TIDPs. So yeah, Nivedita, you can go ahead. Yeah. So this is the Jacob scope, as you can see. So yeah, may not need to go into that much of detail. Yeah, next slide. And this was one of the smart motorway projects. So M6 J13 to 15, and we have a video there, so which you can see. And this was again a BIM level 2 project. Is the video running? Bit of technical issue perhaps. Okay.
Just a moment. I'll just share the.
Yeah.
I was trying to unmute myself. Is it visible now?
Yeah, that's visible.
Oops.
So let's watch this video. Again, this is from that project itself. So.
The busy stretch of the M6 between Junction 13 at Stafford and Junction 15 near Newcastle-under-Lyme and Stoke-on-Trent is a crucial part of our strategic road network and an important element of Highways England's plan to create a smart spine connecting London and the North West. But when so much traffic is travelling to and from one place, that causes congestion, making journey times less reliable and pushing the capacity of the roads to its limits. That's why Highways England is developing an all-lanes running smart motorway in the area to manage the traffic in more intelligent ways, increasing the capacity of the road without the need for major construction. Here's what we're doing. Introducing new technology to monitor traffic on the road and set variable speed limits will avoid stop-start traffic and ensure smoother journeys. These new signs and signals can also be used to close any lane or motorway when an incident occurs. This allows us to convert the existing hard shoulder to an extra lane, increasing the capacity of the road without the need to widen it. You'll still have a safe space to pull over in the event of a breakdown though, as we're constructing 20 new emergency areas with emergency roadside telephones. This means if you're driving at 60 miles per hour, you'll reach one every 75 seconds on average. We will be hardening the central reserve and installing a new reinforced barrier to improve safety for the travelling public and reduce maintenance requirements. The work will also reduce the risk for maintenance teams. Because of low headroom over the hard shoulder, the existing Burton Bank footbridge will be demolished and replaced with a new bridge. We will also be upgrading a number of underbridges to provide the additional width required to convert the hard shoulder to an extra lane. We will be installing nearly 2 kilometres of noise barriers in built-up areas, which will double the existing provision. We will be removing the already redundant Creswell Home Farm overbridge to improve the safety and capacity of the slip roads at Junction 14. We will be making improvements to the slip roads at Junction 15 to make it easier and safer to use and improve visibility. We can't tackle Junction 15 to 16 immediately, because it would need extra land and a development consent order, which would take too long and cost too much to be justifiable. So there you have it. That's how smart motorways will make your journeys between Junction 13 and Junction 15 of the M6 quicker, safer, and more reliable.
I'll go back to the presentation.
Yeah. Yeah, so next slide. Yeah, so this is a cross-section, a screenshot from Civil 3D. So as you can see, the 4 lanes built in there, along with the central reserve and the slot drains that you have on either side. And left side, you have the verge and earthworks. So this is a cross-section from Civil 3D. Next slide. This was a fly-through, sorry, but this is just a screenshot from that fly-through. So that fly-through, we don't want to play it right here. It's a quite long one and heavy one, so we'll skip that. This is again a similar screenshot from Civil 3D. So as you can see, the retaining wall has been introduced there on the right side. And this is the other side of the carriageway. So the central reserve barrier you had on the other side, left side, and on the right side you don't have a barrier there. And this is a screenshot from the Navisworks federated model. So you can see the chain edges and whatever, means everything is built in there. The CCTV mast, the railings, retaining walls, whatever, the traffic signs, gantries, everything is inputted there. Next slide. Yeah, this is a better view, I think. So in the vicinity of the slip road. So yeah, means you can understand how the federated model looks from this screenshot. And this is for M20. Again, this is actually much better in terms of understanding the road markings and other things. But in the distance, you can see there the gantries, everything. So it contains basically everything. This is what a federated model is about. And if you go into Navisworks, you can just navigate in Civil 3D to go underneath the road to check clashes. You can move to the side of the road, wherever you want to go. You can just navigate and check for clashes. Next slide. Yeah, so M20, we have already discussed this. So again, this was in this was a smart motorway and done in BIM BIM level 2. So yeah, and this is from our InfraWorks screenshot. So the level of visualization, you can see each and every tree, each and every traffic sign, structures is visible there. Next slide. Over to you, Nivedita.
Yeah, I'll take over from here. Thank you, Saurav. The next project that we are showcasing here is the Oxford to Cambridge Expressway. This was a stage 1 project and first of its kind that was done from outside UK. So that's the reason why it has an emphasis. And then it is also a BIM level 2 project. Just to relate back to a video that I had shown at the very initial stage where we were doing a concept planning. So this was actually exactly a similar kind of a project where we were doing a concept design, and we had to be mindful about the constraints that were in the site. So if you remember the video that I showed, so it took into account what was your noise level, it took into account what was the constraint that you have at site to actually find something that is feasible to be built, which we also call as a buildability. So it is not about just designing and modeling. It is also about understanding if that can actually be built on the road as a final product on the ground, basically. So this is again one of the InfraWorks modeling that has been done, and this is how you actually see it in the Navisworks. So what Saurav was mentioning, this kind of shows that the road is passing under and your junction is on the top. So these are the kind of the processes that you can actually do when you have a BIM compliant model and all your models are put together into a platform for you to check the clashes, understand where there are issues, if at all they are, and all of these are being done at a design stage. So you don't have to reach to the construction phase to have surprises, to find something that is not supposed to be. So the next is an M20 Junction 10A project, and this was a stage 5 project that we had done, and this is a BIM level 2 project here. And what we will, I'll kind of show you one of the videos here, and it is a fly through that has been made from a Navisworks federated model. So it hasn't gone through the ramping up through a visualization and stuff, but it is just a Navisworks video that has been created as a fly through to make you understand what actually happens when we go ahead and do a project that has been into a federated model, and what does an exact fly through look like. So you can actually design it, put it into Navisworks, and see how your entire road looks like. So I'll just start the video. And you can see how all the details, be it the chevron markings, the road lane markings, your flyovers, gantries, even the fencing, to a certain extent what the landscaping is to the side of the road, everything is visible, and that can be done at multiple stages of the design. As you go ahead and progress with the design, you can do it at several stages. You don't need to do it at the end. So basically you can see how your design is progressing, where you need what kind of an additional detail, This is what a gantry looks like on a Navisworks model. So even the lighting columns are visible. You can see the kind of the landscaping that is being done, your fencing, road restraint system, everything is put together into a one federated model. And this is a kind of a view from the top, just to understand how the scheme looks like. And they all again have their asset data inbuilt into it. So while Saurav was talking about the non-graphical data or the asset management, all of these lighting columns, all of this, each and every element that has gone into this model actually has an asset data management for the contractor to actually go ahead and operate and maintain it when necessary during the scheduled maintenances. I think, Saurav, we can stop the video here, because that's pretty much gives an essence of how a federated model looks like with a fly through.
Yeah,
And
sure.
yeah, so I'll just stop the video. And just to conclude it, what is a successful BIM? So successful BIM is all about following the 3 steps of starting the project with the end in mind, having the right first time mindset. And of course, it's all about CCO, that's communication, collaboration, and openness. That is how we can have a successful BIM. And the applications are just do it. It is not an optional. That's when we all drive as we go ahead, and it comes from the top. And it's all about everyone working together. So everyone has to work together for a BIM project to be successful, or the BIM application to be successful. I think with this, we have reached to the end of our presentation. And thank you everyone for listening to us, and I hope that you might have found it informative, and probably it gives you an insight about what civil engineering actually has in a wider platform, and what all you can go ahead and do when you once come out of your colleges. Thank you.
So I would just like to summarize the whole webinar session number 4. We spoke about the different styles of communication, and then further in the domain of BIM, we spoke about BIM dimensions, construction maintenance, cost and safety, the models for successful BIM, individual 3D models in their native file formats. Then we also spoke about the different processes that are involved in generating a BIM model, the BIM toolkit, and how we can increase efficiencies through early problem detection, how data is handled in graphical and non-graphical manner, and the common data environment, and how business value is derived from BIM. Also the maturity levels, level 0, 1, 2, and 3, and the region-wise demand for BIM, where UK is dominating the whole demand across the globe, and how India is also showing a significant interest in BIM. So I would like to thank both the speakers, Ms. Nivedita and Mr. Saurav, for enlightening us on the various aspects of BIM and giving us an in-depth and knowledgeable presentation. Thank you so much for your participation, and attendance. Thank you, Nivedita.
Thank you.
Saurav.
Thank you.
Thank you.
I think there are no queries, so all good in that way.
Yes.
Yeah.
So we will be sharing a feedback link in our email. And thank you so much. You may now leave the meeting.
Thank you.
Thank you, everyone.
Thank you.